my presentation over databases, the one that we studied this week, which was PostgreSQL. So first, I thought it would be good to just discuss what exactly a database is. So this is essentially a organized collection of data that gets stored in a computer system. It allows users to access and manage their data in a more efficient manner. So at the core of this are the database management systems, or DBMS. Some popular examples of this are MySQL, PostgreSQL, Oracle, and Microsoft SQL Server. Each of these systems is going to provide tools for users to create, read, update, and delete their data, which is commonly referred to as some CRUD operations. Data within the database is typically organized in tables, which consists of both rows and columns. The row is going to represent a record, and the columns are going to correspond to an attribute of that record. So, for example, you could take a coffee shop that's full of customers. A row would represent the customer, whereas a column would represent an attribute of the customer, like their name or the type of drink that they ordered, or I don't know, their hair color, whatever. Just an attribute of the specific record. Databases are also just used everywhere that you go. So you can see them used in banks to manage the accounts and transactions. Schools, they use them for student records, and grocery stores can use them for management of assets such as their inventory. Furthermore, databases are also categorized into several types. So you can have relational, distributed, or cloud, NoSQL as well. So a relational database is like PostgreSQL, which we'll be talking about here in a second. This stores data it stores data in tables, and distributed databases are they spread the data more across multiple different locations, while cloud databases are hosted on the remote server. NoSQL databases, on the other hand, are flexible, and the data storage without a fixed schema to them. So getting into PostgreSQL and what this is. So just a little overview of it. This is a relational open source database management system. It's going to support a large range of data types, integers, Boolean, JSON, XML arrays, and more. This allows developers to have a lot of function in the way that they store their data. Another key feature is that it accepts the user-written code, which just furthermore extends the capabilities to suit specific needs of an organization. And additionally, it offers advanced text searching options, which makes it easy to queue the text-based data. Multi-version concurrency control, or MVV, is also utilized here. This is going to enhance the performance of concurrent transactions. Its advanced query planner optimizes query execution, which is going to improve the efficiency. Partitioning is also another important feature here, which allows the larger data sets to be divided into smaller, more bite-sized pieces. PostgreSQL can utilize multiple CPU cores as well, which is just going to further the efficiency of the database. Along with this, you also have FDWs, the foreign data wrappers, which enable it to access data stored in external sources as if it were part of the database itself, which just goes into making it so much, it makes it very highly scalable. Additionally, it by default listens on port 5432. So getting into the first hardening recommendation, I wanted to cover TLS, or the Transport Layer Security configuration for PostgreSQL. So this is going to, as it always does, encrypt the data during transmission. So this prevents your eavesdropping and your man-in-the-middle attacks. Without this, data gets sent over in plain text, and this is dangerous and can lead to sensitive information getting intercepted. So to implement TLS, it's a requirement that both the client and server systems support OpenSSL. So on the PostgreSQL side, the first step here is to download OpenSSL and enable it by setting it to on. Next, you'll need to create an SSL certificate for the server and ensure that it's stored in a secure location. Um, and this is going to play into the second hardening recommendation, which I'll talk about in a second. But after making any changes to the configuration, and after you store the keys in the proper place of the database, you go ahead and restart the server, and the effects will take change, or the changes will take effect. So the second hardening recommendation I had was the TDE, the transparent data encryption. So this is used to encrypt the database files at a rest. So it's going to protect the data while it's just sitting there, being stored inside of the database. It ensures that information on the disk is unreadable without proper authorization first. It requires minimal changes to the PostgreSQL core code base, which makes it a very practical solution, as it's not going to really mess up with any of the processes. Um, it employs a internal key management system to store the encryption keys, which ensures that access is controlled. Data is also encrypted during file system input and output operations, while unencrypted data is going to remain in the shared buffers for performance of the database. Additionally, the write ahead logging wall data is also going to be encrypted, which furthers the security. Um, Additionally, TDE is compatible with replication processes, which is good because it's going to allow the encrypted data to be sent across different locations, which once again just plays into the scalability of this. So in conclusion, it's a strong layer of security for the data while it's at a rest and not being used inside of the database. And finally, I wanted to cover role-based access control, or BAC. So this is a security structure that's going to manage the access control based on a user-specific job or function within the organization. Essentially, this just protects the sensitive data by only allowing the users with proper credentials to access the information based upon their role within the organization. Um, so this is going to implement the principle of least privilege. This is fundamental to role-based access control. It's going to ensure that the user is granted the minimum level of access needed in order to perform their job function. So in PostgreSQL, you can use the create role command. It's going to establish the role, and then following that, the grant command, which is going to assign the permissions accordingly. PostgreSQL also includes a lot of predefined roles, which really help in simplifying the process of setting up access control for the database, which once again, as mentioned in every single slide, um, it really just plays into the scalability of this database, which is kind of the overall concept of making a really solid database. You know, when you have an organization um, that contains a lot of information, its scalability is going to be so vital to the company's success in its business endeavors. So, yeah, that's my presentation, and thank you for watching.